So hello guys, today we are going to discuss this problem K Radius Subarray Averages. This is a problem from the daily Leetcode challenge, and the problem goes like this. Let's understand the problem first. So we are given a array, for example this array, and we are given a number K. So let me draw a array, something like this, right? And we are given a number K. So here K is given as 3. So we are supposed to find out a average um, uh, subarray around this element. So let's read the question. You are given a zero indexed array nums and nums of n integer and n integers and an integer k. The k radius average of subarray nums is centered at index I with radius k is average of all elements and nums between I minus k and I plus k inclusive. If there is less than k elements or before, after the average radius, k radius average is minus 1. Okay, so let's see this from here only. So we are given k3. So we'll move at the first element, that is 7. So there are uh, 0 elements before the index 0, that is element 7. So we'll place minus 1 here. On 4 there is only one element, but we want at least 3 elements before it, so we'll place minus 1. At index 2 there are only 2 elements, 7 and 4, so we'll place again minus 1. At index 3 we have 3 elements before element 9, that is 7, 4 and 3, and we have 3 elements after element 9, that is 1, 5, 7, 1, 8, 5. So what we'll do is we'll calculate the average of these items, that is 7, 4, 3, 9, 1, 8 and 5, and we'll divide it by 7, right? So we'll sum all these elements, 7, 4, 3, 9, 1, 8, 5, 9 and 8, 5, this is here, and we'll then divide it by 7, and whatever the output is, we'll provide it. So again, the thing to note here is we'll do an integer division, that is 37 by 7. Whatever the fractional part is, we'll ignore it and we'll just keep the integer part. Then we'll move to the next element. So in next element, we'll just sum the 7 elements or the 3 elements before 1 and 3 elements after 1, that is this blue line, and we will calculate the average. Okay, so let's see here. So when we are at uh, index 1, we will be calculating average of these 7 elements provided that k is 3, because we'll have 3 elements before 1, 3 elements after 1. Then we'll move at element 8. So on element 8, we'll take average of 3 elements after it and 3 elements before it, so it will become this. And when we'll move at element 5, that is this element, we'll we do not have 3 elements after 5, so we'll take it as minus 1 here in the output, minus 1 and minus 1, because we cannot find the average of we do not have the 3 elements k elements after 5. So how we are going to do it? So initially the plan is we are going to initialize a array with minus 1, which is of same size as the input array. So here the input array size is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll do 9 minus 1s. So this becomes 3 and 9 minus 1s. Okay. Then we'll start traversing our input array, that is this array. If we take this array again, let me take this array again. So now, since we know that if number of elements before an element is less than k, so we are not going to calculate the average, so we will skip k elements from front and we'll skip k elements from last. So what we'll do, we will um, skip k elements from front and we will skip k elements from last. That's it. And then what we'll do is at this element, that is at 9, we will calculate the sum of first three elements, next three elements, and the element itself. So we'll be calculating sum of these three. So skipping here means that we will keep all minus ones here, and we'll take the sum, which will be equal to 7 plus 4 11 plus 3 14 plus 9 23 plus 9 23 plus 9 will become 32, and plus 5 37. So we will make this as 37, right? And then we'll move to the next element, that is 1 here. So when we'll move to the next element, we will take sum of three elements before 1 and three elements after 1. So if we can see here, we are like, this is a sliding window problem. We will be removing 7 from 37, that is we will do 37 minus 7, and we'll add 2 into the sum, right? Because all the elements, rest elements are same. So this sum, red sum will be equal to 37, and blue sum is equal to one element, um, that is which is not in the window, and one element which is included in the window. So it will make up 37 minus 7 plus 2, which will it will be equal to 32. So we'll replace minus 1 with 32. And similarly, we will move to the next element. Let me pick up. Okay. So in the next element, when we are at element 8, so what we'll do? This will be 8. So in 8, if we can see, we will skip 4 and we'll include 6. So what we'll do is 32 minus 4 plus 6. So this will become 34. So we'll replace this and we'll make it 34. And then before sending the output or calculating the output, we will calculate the average. So here from this input array, this is the input, this is the sum array actually. What we'll do, we will calculate the average as all, for all minus ones, we'll not do anything. Otherwise, average of I will be equal to average of I divided by 2 multiplied by k plus 1, right? Because 2 multiplied by k plus 1 will be the number of elements. So if k is 3, then we will take divided by 7, because in one window we'll have 7 elements. If we see red, 1 2 3 4 5 6 and 7. If we see blue, 1 2 3 4 5 6 and 7. And similarly for the pink, we'll have 7. So we'll return this one. So the time complexity of this algorithm would be on, because initially we will be calculating this sum array, and then we'll be again traversing the sum array, or rather I'll say it will be on minus k. So if k is very large, then the time complexity can reduce significantly. So let's go into the code now. Okay, so in this so this is the output array, which is of type int, because you have to return int. This is the sum array, which is of type long long. So in every step, we are just calculating the sum and keeping it in this sum array, because if we keep average, if we calculate the average in every step and we keep it in the average, then we'll lose the precision thing. So if it is 37 divided by 5, we'll only store 7, but we and for the sliding window, we need to have 37, because then only exact average can be calculated for the next element. Okay, so what we have done is we have initialized um, our sum and nums array to -1. We are skipping the first k elements and we are skipping the last k elements. See here, in this array, in this loop, we are starting from k equal to 1. So for example, if k is 3, so we'll be starting from 9 here, and we are going till size minus k. It means we are going till 8 only. 9 1 and 8, three elements we are going to calculate, right? Because all rest will be ones. So if this is the first time, So if this is the first time, because for the first time only we have to calculate all the sum. First average is true. So we will be going in a while loop from this element to the very first element. So here j will be equal to 3 and I minus k will be 0. So we are going from 3 to 0 and we are calculating all the sum. Then we are making j is equal to I plus 1, that is j will become 4, that is we'll start from 4 and we'll go to I plus k. So I is 3 here and k is also 3 here, so we'll go till 6. So we'll add 7 4 3 9 1 8 5. So we'll have sum here and we'll store it in a sum array. And when then exactly after first step we'll do average first is equal to false, because next time we are going to slide the window and we are just going to reduce the first element and add the last element in the window. So at k equal to 3 we have calculated the sum, we are at k equal to 4 now. So since first average is false, we'll directly fall in here. So sum array 4 will be equal to sum array I minus 1, that is whatever the sum we have calculated for this sum array. So okay, so let us go here. So uh, let me clear it. Okay, and let me take it here. So this is our right, and we will have a sum array which is equal to minus 1 minus 1 minus 1, and for 9 we'll have for index 3, that is index 3, we'll have um, 7 plus 4 11 plus 3 14 27 plus 4 11 plus 3 um, 14 14 plus 9 23 23 plus 9 32 32 plus 5 37. So we'll have 37 here. In place of this we'll have 37. Okay, now we are at index, this was index 3, this is index 4. Now we are at index 4. Let me also name 1 2 3 4 5 6 7 and 8. And these are the indexes, right? So now we are at index 4. At index 4, what we are going to do is at index 4 we will subtract, so we'll have this array or this window, so we'll remove this earlier window was this one, right? So we'll remove this and we'll pick this. So for index 4, that is at 1, what we'll do is, let's see in the code. We are removing nums of I minus k minus 1. So I will be equal to 4, k will be 3 minus 1. So it will become num 0. And we are adding I plus k. So I is 4, k is 3. So it will become 7. So we are adding 7. So removing 7 and adding index 2. So whatever the sum is. So it will become minus 7 plus 2. It will be minus 5. So it will become 32. And similarly, we are going to calculate it for all the other elements. Then what we are doing here is we are dividing. So we'll have a sum array here, something as 37, 32, and let's suppose this will become maybe 48 or something, right? So we will calculate 37 divided by 2 into k, which is 2 into 3 plus 1 7, and then we'll calculate 32 divided by 7. So this is the step we are doing here, because we have to return the average and then we are copying it into an integer array. So why these two long and integer array are different? Because in the question is given that the number length can be the number n, number I will be greater than 0, and number I, nums I, can be up to 10 raised to the power 5. So if we add up multiple 10 raised to the power 5, that is um, 1010, 1 lakh numbers consecutively, then it will add up to a very large number. And if we keep on adding in some in this average array, it will overflow. So we are taking sum in long, we are calculating average in integer vector, and then we are returning the integer vector, and it works. So this is accepted solution. So thanks a lot, guys. Have a good day.